The cooling system is also essential to the engine. Let's take a look at it. To operate an engine efficiently, the engine must be maintained at an appropriate temperature. Excessive high temperature will result in abnormal expansion or seizure of parts. Too low a temperature, on the other hand, will cause increased fuel consumption and accelerate part wear. To maintain an appropriate engine temperature, it is not sufficient to simply prevent the engine temperature from rising. It is also necessary to raise the temperature quickly to an appropriate value when it is low. In general, a water cooling system is adopted for the cooling systems of vehicle engines. A water cooling system is mainly composed of a water pump, which circulates water as coolant through each engine part and the heater system. A thermostat, which controls coolant temperature. A radiator, which radiates coolant heat to the atmosphere. And a cooling fan, which enhances the radiation performance of the radiator. In this cooling system, coolant circulated through the water jacket absorbs heat generated by the engine, thereby lowering the engine temperature. After the absorbed heat is radiated to the atmosphere by the radiator, the coolant is returned to the water jacket for circulation to cool the engine. There are two coolant flow circuits interswitched by the thermostat. When the coolant temperature is low, the thermostat closes, shutting off coolant flow to the radiator so as to warm the engine quickly. The coolant from the water pump then flows through the cylinder block and cylinder head, returning to the water pump via the bypass. When the coolant temperature becomes high, the thermostat opens, allowing the coolant to flow to the radiator, thus maintaining an appropriate engine temperature. Now, let's look at the main parts of the cooling system. There are two types of cooling systems in terms of a coolant bypass circuit: the inline bypass type, in which the bypass is open at all times, and the bottom bypass type. Most engines use the bottom bypass type. In the bottom bypass type, the thermostat is installed on the coolant inlet side and has a bypass valve. When the thermostat opens, the valve closes the bypass. Compared with the inline bypass type, the bottom bypass type has greater cooling efficiency and less fluctuation in coolant temperature, and therefore achieves more stable engine temperature. The thermostat functions to control coolant temperature. As described earlier, the thermostat opens or closes depending on coolant temperature. Normally, the thermostat starts to open at a coolant temperature between 80 and 84 degrees Celsius and fully opens at 95 degrees Celsius. If the thermostat is closed when coolant is injected into the cooling system after drainage, engine side air will remain in the cooling system, hampering coolant injection. To avoid this, the thermostat has a jiggle valve at the flange. Engine side air is drained through this valve to facilitate coolant injection. The water pump forces coolant through the cooling system. The rotary motion of the crankshaft is transmitted through the timing belt and V-belt to drive the pump rotor. The pumping function of the rotor circulates coolant in the cooling system. The gap between the rotor and water pump body is mechanically sealed to prevent coolant leakage. If coolant leaks through the mechanical seal, it can enter the bearing section. To prevent this, the water pump is provided with water drain holes. Coolant leakage can be checked through these holes.